My name is Ram. I work as a software engineer on the infrastructure group at Etsy. And for those that haven't heard, Etsy is an online marketplace that enables sellers to pursue their craft and at the same time provides an avenue for buyers to find really unique goods. And this talk is going to focus on options for invalidating cache, which is based on a project we did in a prototype phase at Etsy and what we found during that. During the talk, we'll look at caching really briefly and then talk about Nginx very briefly as a caching server and then get into the invalidation part of it. Caching, what is it? In a general sense, it's you either store the result of an expensive operation or you save a copy of a data that lives elsewhere. And when you look at web applications, you usually find two kinds of caches. There's local-side caches and then pass-through caches. A local-side cache is when you have to explicitly look for something there, and then when it doesn't exist, you go to the origin. Then when you get the result back, you again have to explicitly store it there. Whereas a pass-through cache, it's already set up to just do all that work for you. Once you talk to the cache, if it can't find it, it'll go to origin and then populate its cache. And in terms of software, it looks like Memcache, Redis, etc. fall in the local-side cache category, whereas Varnish, Nginx, etc. are in the pass-through cache. And the general theme here is HTTP caches is what you find in web apps a lot, and that's what we'll be talking about, and more specifically, we'll be talking about Nginx. So say you have requests going from your client, which could be either actual browsers or phones, or it could also be server-side software that is talking to your origin. And you just inject Nginx into the path here with the expectation that it'll absorb requests on cache hits. On the first request, when you see a request for a resource the first time, it'll become a miss. We'll go to the origin, populate it. The next time you see that same request, it'll become a cache hit. This is all kind of hand-wavy because it's under the assumption that you're doing the caching headers right and the server is set up right. And to do that, this is kind of a basic Nginx config that turns it into a caching proxy. And this could potentially let you start your own CDN, but don't do that. There's a whole lot more that goes into that than this 15-line config. And there's a few more things that could go into that config. I listed them here because they come up later on in the talk, where they make sense later. The first is the cache status header, where you know what the cache status of the request was, usually hit, miss, bypass, and etc. Proxy cache lock, which is a feature that lets you do collapse forwarding of requests, where multiple requests, when they arrive at the same time for the same resource, you can turn them into a single request to the backend. It helps you prevent thundering herds. And the next two are more about forcing a cache on the server, even though the origin doesn't tell you to cache it. And the bypass directive will again it'll make sense later. And the last one is to keep connections alive to the backend so that you're not reopening a new TCP connection every time. So that's kind of the gist of caching and Nginx. Well, you can go start your own CDNs now. Invalidation is the bulk of this talk because that's kind of the work we did to figure out some details, and I think that's the more interesting bit. Can't really talk about invalidation without this joke that you guys have probably heard some variation of. There are only two hard problems in computer science: naming things, cache invalidation, and off by one errors. So on that note, we'll just look at the invalidation options. So depending on what kind of Nginx, let me take a step back. Nginx is kind of this turned into a base event loop plus a bunch of features that people have built on top of it. Like Nginx, the company has built Nginx Plus, which adds a bunch of features on top of the open source Nginx project. And then there's another distribution of Nginx called OpenResty, which takes Nginx and adds an opinionated set of modules, and it builds another distribution, you can call it. And we'll look at invalidation options with each of them. And the first one being for the open source version of Nginx. We'll look at a module called Nginx Cache Purge, which was created by this consulting firm called Frickle. And actually, the author of it is in the audience. That's why I'm laughing. If you use it, you can say thank you to him. So this is, again, an example config. And the most important line there is that one line where you say proxy cache purge, purge from, and an IP. So you're kind of doing a few things there where we're specifying. So by placing it in a location that already has a proxy cache directive, you're telling it which cache to purge from, and it also infers the cache key. And you're saying if it's a purge request, that if the HTTP method is purge instead of a usual get post, etc., and if it comes from the local host, that's the access control part, then remove that entity from cache. If you have any limitation around where you can't use the purge method, then you can also do a separate location block with a prefix and basically match the rest of the URL, with the expectation being the URL you want to purge, you would prefix it with something, in this case the word purge, extract the URL, and then use it in the cache purge directive. And again, there's the allow deny directives which do access control. It's a beautiful idea. It's super simple, and it's about 1,000 lines of code, and you can go look at it and it'll make complete sense. And it's a good thing that modules exist and that open source versions of Nginx can have a purge option for it. But the only trick is that you have to recompile your Nginx to include this module. It doesn't come default. The other option is Nginx Plus. Say you're running Nginx Plus, use all the good things that come extra with Nginx Plus. One of the things that it comes with is the proxy cache purge directive, which coincidentally is also named the same as the one from the open source module. The way that works is this is a full config, and more specifically, just those, the line at number 13 is the one we care about. It just says proxy cache purge, purge method. And again, here there's the assumption that you'll put it in a location block that has proxy cache already set up. And the map will do when it's a purge method, do the purge. The other nice addition to that directive that comes with Nginx Plus is you can do prefix match and invalidate, or to be specific, purge a bunch of objects that have that prefix from the cache. So you can do multiple, but you can only do it if it matches a certain pattern, and it has to be the pattern has to be at the end of the prefix. So that's the other option where you can do things in groups, but not as flexible. And the last one is the group cache invalidation method, which is something we worked on at Etsy, and we'll talk about how we built it and why we built it. So to do that, we'll talk briefly about what Etsy's use case was and why the other two didn't fit for us. So taking a step back, we run a large API that does several thousand requests per second, and actually another step back. So Etsy has sellers that open shops, and their shops have listings. That's kind of the main business entity of the website. And the graph on the left, what it's showing is that we did some math with one of our data scientists to check what does listing access pattern look like. And what we found was that the majority of the listings that people see are seen less than 10 times, which means less than 10 other people are seeing that listing, which kind of is points back to the uniqueness of the products that are sold on Etsy, where there's no few hot objects that you can just cache. And the other thing we looked at is that if that's the case, then how big does our TTL, the time to live in cache, has to be in order for the cache hit rate to cross the 50%, 50 plus threshold. And it looked like we needed to cache for more than 12 hours. What that tells us is that things would be in cache. If something changes, they would be stale for up to 12 hours. So that's not a product, that's not something product was okay with, which meant we needed to do active invalidation of these objects in cache. And the way we would know that data changed is by tailing things at the source of the truth, which is the database. So basically take database bin logs, put them in some message queue so that it's available as a stream, and invalidate objects in cache. But the tricky bit there is that there's this disconnect between what the cache thinks it has and what you see as changing. So the cache is aware of URLs, right? That's how it identifies objects. Whereas the database looks at things as tables and rows. So we needed a way to map one to the other. That's kind of where the grouping concept comes from. So what we wanted was to be able to invalidate cache entries, not just on the URL, because sometimes database rows end up in multiple entries, or other times they're made up of multiple database rows, so there's no one-to-one correspondence. And the way we solved this is actually, it was a Hack Week project where we basically sat down and decided to take up OpenResty and see if we could build this. So a little bit of backstory here is that we actually looked at what's available out there, and people that have already implemented are Fastly, Cloudflare, Varnish Plus. They've all have implementations. The thing is, we were not quite ready to put our data with all these tags in an outside entity's hands, and at the same time, the invalidation levels they were offering didn't look like they would be quite sufficient because of rate limits. But I'm sure when we go production ready, we could probably work something out there. But we wanted to see how could we take this great caching server Nginx and layer this feature on top of it. And the way we did that is using OpenResty, and the features we use there are the Lua Nginx module, which is the bulk of OpenResty's feature set. And then it adds a whole bunch of other things on top of Lua being available by using its content phase handler. And then another feature it exposes called shared dictionary, which is basically a memcache-like storage within Nginx available in Lua. So if we go back to the slide earlier where we looked at Nginx as a cache, we replaced that with OpenResty, which is basically still Nginx under the hood. And the two things that we needed were, we needed the origin to send a header called xGroupKeys, which tells the cache what keys made up the response. So that way, as the cache fills up, you kind of have the keys overlapping and you in some way group them. You can think of it similar to how you tag blog posts or put them in categories. It's a similar concept. And the other part we needed was in the caching server itself, we needed additional logic in the content phase handler, which we'll get into in a bit. And the other one was an invalidation endpoint that could invalidate groups. So going back to the origin, the response header looks pretty simple. It's just a list of space-separated strings. And the majority of this lives in the cache server part. And the origin side, it also was easier because we have an ORM. We added a hook into it, and we basically tagged it with database rows using the table name plus primary key. And we take that and see how we can group things in OpenResty. So to see how we did it, let's look at a request response cycle. Say we get a request for get listings/ID. On first request, it'll be a cache miss. It'll end up going back to origin, and the origin will add the X group keys response header, which will, as I said, will be made up of the database rows that were read to make up that response. And this is when the response comes back to the cache, and that's where the bulk of the logic happens. So the first thing that happens is Nginx stores the response in cache, as it usually does, and then it yields to the Lua code that was injected as part of the content handler. And what that Lua code does is it parses the X group keys header, and the individual keys, which are basically just strings, are stored in the Keystore, which is the shared memory zone we talked about, referred to as the shared dictionary in Lua land. And the other minor detail is that we also use a timestamp that came back as a way to identify when this key was last known to be valid. Once we do that, we just send the response back to the client, and the request response cycle is done. Everything's great. The next time we see the same request, it becomes a cache hit. In this case, Nginx loads the response, which includes headers and body, which is a nice feature where I think it's a general feature of just caching servers where they store the headers along with the body. And then again yields to the Lua code in the content phase handler. And this is when we do the real check of is this response valid? So the other thing that's important to note about this model is that the responses are actually never purged. They're only marked as invalid based on the keys that they're tagged with. So each time we load the response, we also have to check, is this response still valid? And the way we do that is when we loaded the response, we parse the header, get the keys, and we check in this key storage, which is still a part of Nginx. It's just a shared memory zone that you can do get and set and add operations on. We load each key and check what is that key present in that key storage. And also, if it's present, is the timestamp associated with it newer than the date header on the current response we're looking at? And if any of them has been invalidated, which is if it's not present in the Keystore or if the timestamp is newer, what we know is that this is, again, a way of setting expectations that if either of those things happen, then assume that that key has changed. And what we did by doing that is exposed a way to invalidate these keys, which is just remove them from this Keystore, and you've essentially invalidated because the check happens at every request. It's a way of lazily invalidating the actual responses, but we are actively invalidating these keys that group the responses together. Any questions? That was a lot. Yeah.
The Keystore that you're referring to, is that in OpenResty in that layer?
Yeah, it's all hidden inside that one block. Yeah. Cool. Let's take a look at what this looks like if we built it out in code. And then we can go back to talking. Oh, hey, sorry. So you just delete it from the Keystore, and I'll show you how we expose that as a feature to the outside world. But basically, we go find it in the group Keystore, which is the shared memory zone, and then remove it. Do a delete operation. How do you know they're deleted?
How do you know that you need to delete it? Because presumably that information is over in the
Right.
actual app.
Yeah. So yeah, that's the other part that's outside of the Nginx part that we had to build. Is basically we need that database changes that went into a messaging system, which was Kafka, and you take that and you invalidate. So this is overly simplified, but it kind of conveys the concepts. So the bulk of the requests are handled by that first location block, which is saying capture everything and then let this Lua file handle the content for it. And the second one is if there's an endpoint called groups invalidation that gets hit, then let that be handled by the second location. And then there's a third one, which is an internal location, which is set up with a cache. This is a usual caching proxy setup. The reason why this exists is so that we can make use of Nginx's core functionality while at the same time adding some Lua logic on top of it. And the last feature is the shared dictionary, which is, again, you can think of it as a memcache that lives inside Nginx, and it's built on top of shared memory zones, which are used all over Nginx. It's the same thing that's used by Nginx to store its cache keys. So it's not a new thing that was built, just the API is new. So what does an API request look like? This is, again, overly simplified just to convey the concept. So the first step is when we say make API request. What that does is it fires off an internal sub request to the second location that has the proxy cache. And once that request comes back, which is all the things that happen behind the scenes are just handled by Nginx. And when that sub request finishes, it yields back to this line of code. And there we check, is the request a cache hit? And the way we do that is by checking the cache status header, which we talked about much earlier. It's just a header with a string that says hit or miss. And then we check, are all the the group keys valid? This is where we hit the, the group Keystore, which is the shared memory zone, and check, are the timestamps on it? Or can we find all of them in that store? And are the timestamps checking out? And if any of them is a miss, as in if any of them is considered invalid, we do another request by bypassing cache, which is, again, a feature built into Nginx. We take advantage of it by saying add. You can set it up however you like, but the way we did it is by adding a header that says bypass cache. And the nice thing there is that instead of reading from cache, this time Nginx goes back to origin and then repopulates the response in cache with that new response. So you kind of get two features out of it. And then what's left out of here is that we will be storing the group keys into the shared memory zone when it's not a hit. We're only seeing the hit part of it. But that's kind of the API request part of this. The other part is, how do you do actual invalidations? The invalidation is the even simpler part, where we exposed an endpoint that was a second location block, and this is the Lua code behind it. What we do is we say, get the key we want to invalidate, that's the line 1. Line 2 is load the Keystore, which is just a default operation, and then line 4 is where we actually delete the key. And by deleting it, what we did is that the next time we do a check on a request, it'll fail because the key won't be found in the store. Or if something else adds the key back, the timestamp of it will be newer, which means the response we have in cache is stale. That's the pointers. And that's kind of the gist of it, where with a few lines of Lua, obviously there's a lot more behind the scenes that happens, but the high level concepts are these. And by taking advantage of Nginx as the core caching server and by layering some Lua logic on top of it, we built a group invalidation server. And just sharing some numbers, we ran this cache. We didn't run it in production, but we teed production traffic from the load balancer and sent it to this tier. And we were able to handle about 1,800 requests over 2 bare metal servers with a cache size coming up to 2 terabytes when it filled up over the course of a week. So it's pretty performant is what I'm trying to say because of Lua and the JIT that comes with it. back to the options. So we looked at 3 different options. There's the really basic one that comes with Nginx open source version, which is, it's pretty simple idea where you say, I want this thing removed, it goes away. Nginx Plus also has that feature, but you can also do prefix matching. And the last one is OpenResty, which, by the way, that's their new logo, which got launched, I think, a month or so ago, which lets you write custom logic on top of your content/access log phase handlers. And the idea I just demonstrated is what you can build, the power of what you can build on top of it is great. And the credits part is there's obviously none of this would be possible without Nginx. So thank you, Igor, and the rest of the team. And then Piotr Sikora, thank you for the Nginx cache purge module, and Yichuan and a bunch of other open source contributors are the ones maintaining OpenResty. And thanks to Etsy for letting me work on this prototype during Hack Week and then continuing it on later. And thank you all for coming here and listening. Cool. If you have any questions, feel free.
So for the shared memory storage that you guys had on the OpenResty nodes, were you just using a single zone for each caching layer, or were you doing any sharding at all?
So we didn't do any sharding. So every cache had its own shared memory zone. And the way we could potentially minimize things getting sprayed all over is if you use consistent hashing on the load balancer that's in front of the cache.
Did you guys run into any lock contention issues with using a shim zone that large, like 100 megs and that many keys? Seems like you might spend a lot of time just spend locking waiting to get into the zone. Did you run into that at all?
Right. Yeah, that was our biggest fear too. And it turned out that was not an issue at all, because the operation behind the lock is there's no outside entity that you're relying on. You're just walking a red-black tree and then you're done. So locking, it could be contentious when you're talking to something else or depending on some other thing to do an expensive operation. But here it was a non-issue. Actually, the other gotcha we ran into was that Nginx workers would block on disk I/O, which is it's not Nginx's fault. It's a good event loop, but the operating system, if you're running on Linux, it doesn't provide a good way to do async I/O. If you ran on FreeBSD or something that has good async I/O support, you're set there. But this is where Nginx introduced the concept of threads. Yeah, thread pools to get around it. Another gotcha is that OpenResty, when you do sub requests and you do AIO with thread pools, there is a bug where it doesn't work. So it's an open issue, and each one, as he responds to some of the requests, he says pull requests are welcome. So if anyone wants to take that on, that's a good one. Or we could get someone on the Linux kernel to fix async I/O, I guess. I mean, you can you can get around it by using the direct O flag, but what that means is it bypasses page cache, which means you're taking a hit for all requests, even ones that could potentially end up in the in-memory page cache for the disk.
So was that blocking I/O the page loading the proxy cache results? Was that where that was coming from? Because
Yeah.
nothing else in the group key that was storing on disk, right?
The group key is actually stored in memory,
Right.
but the actual object, right, it's not stored on disk. So basically when you do the internal location redirect, when it needs to load the object, that's when it blocks the worker. Yeah.
You have more than one instance of Nginx running all the key value parents.
Yeah, that's a good question. So that's a good trade-off question, where if you run multiple instances of Nginx and you use the shared memory zone, then they live on each of the Nginx instances, which means you would have to invalidate each one, which means your invalidation requests need to hit every single one, which kind of puts you in this distributed synchronization / consensus, whatever problem. But there's an easy way to work around it where in the Nginx Lua module, you can talk to things like Memcache or Redis. So if you create a new, a dedicated pool of group key storage layer using Memcache, say, then you can just direct all your invalidations over to that one Memcache or a pool of Memcache servers. So that's the trade-off. So we ran multiple servers and we had to hit each one with every single invalidation request because they could live on either. Yeah, that's the other thing. If you did a shared Keystore, then you could potentially have the ability to restart Nginx instances because as long as the Keystore stays alive, you can restart. And since we're not actually removing things from cache, even if they load back up, it's fine. Right. We don't, but you could. In this setup, we don't actually delete the file at all. We only delete the key that was part of the response. Sorry, say that again.
Did you open source the code so we can steal it?
Oh, so we haven't open sourced it, but we should. When I get back, I'll talk to people and get on that. Yeah, I mean, there's no reason not to do it. We just haven't because we don't run it in production yet. So, but it's still a reference implementation that other people could use. Hey.
I want to follow up on that previous question. Does the cache persist across reloads, like reconfigurations?
I actually don't know if the shared memory zone is cleared. It's not.
Shared zones are only cleared on a full restart when you
Okay.
do a master process. So if you keep the same master, but just do a hang up, that doesn't go away. Because the master is the one that tracks that arbitrary.
Cool. Yeah, I believe the restart still keeps the JIT alive as well, the JITted code reload, but not the restart.
But JIT's per worker, so when you reload, you kill the worker and you attach JIT.
Oh, really? Take that back. I was wrong on that one. Hey.
Possible mischief, how do you validate the key invalidation calls? Or do you? Could I call it so you destroy your keys for you?
Right. Yeah, so that's another good question where when you run a caching server with invalidation, how do you know it's actually doing?
The worst that can happen is you have to start loading stuff again from the source.
Right. So the way we thought of it is that you could still, for about a small percentage, say 5 to 10% of the requests, even if they come from cache, you load it again from origin because you have the power to run Lua code, which means you can do additional things. So we could potentially load the same requests from origin, even though if it was a cache hit for 10% of the time, and then find out if they match. If they don't, then you have a problem you should look at.
And at least you can detect the fact that somebody was spoofing.
Right. Yeah, we wouldn't know the extent of the problem, but we know there is a problem. Right. Do we sign it? No, we don't. We could. I don't quite. Oh, I see. Yeah. True. Someone here had a question, I think. No?
So do you have a one cache module for the caching stream against caching?
It's a bunch of Lua code and then Nginx config. So there's nothing we had to actually patch the Nginx server itself. Oh, do we do it? No, we haven't done that.
If you're only invalidating the keys from that stream zone, but you're not actually removing things out of the party cache, like the on-disk cache,
Right.
do you have like a cron or something that runs in the background to clear out old stale crap that never got removed?
Yeah,
You're gonna run out of space.
Right. So Nginx already has a process like that. It's called the cache manager, right? So it always runs in the background. It does either LRU eviction if the cache grew past the limit or if it's stale. Yeah. Cool.
I was just gonna mention, I think it seems like the cache manager runs like a lower, like if you have a lot of load on your Nginx,
Right.
the cache manager just won't do that. So you'll actually.
Right. So yeah, I don't think you can. Yeah, definitely. You can't. I don't think you can tune it in the open source one, but I believe in the Plus you can set it to run more frequently. But yeah, that's definitely an issue where the cache could grow until it runs again. So you kind of have to play the game of set your cache limit to something that doesn't cross. That's a percentage lower than your actual disk size, so that it can grow, and you still have time for it to clear up. Yep. Cool. All right. Well, thank you all. Enjoy the drinks.